Anusha. In data analytics, top n queries help us quickly find the most important data like top performers, top customers and so on. So in this video, my objective would be to retrieve nth highest salary from employee records to find top n records like top 5 records or top 10 records to find department wise nth highest salaries, and finally we will see how we can find or filter rows according to top n%. In SQL, we have multiple ways of writing such queries. So in this video, I'll be writing queries using limit and offset, using subqueries and using Windows functions. So let's get started. So first we'll try to find the first highest salary. So you must be wondering, to get the highest salary, we can directly use the select max of salary. But it gives only the number, not the employee details. But what if more than one employee has the highest salary? Then we need to handle ties effectively. So that's why we need proper top-end methods. So here I have an employee table. Using the basic limit function, I am trying to I'm trying to order the salaries in descending order, and then I'm limiting it with 1. So it will display the record where the highest salary is there, and since we limited 1, it will return only 1 row. And in the same way, to find the highest salary employee records, we are using subquery where we are selecting the employee details and we are selecting the record such that where salary is equal to the maximum salary. So this way you will get the employee details with the salary as well. And in the same way, we have something called Windows function. So in the Windows function, we can use rank functions, and here by ordering salary in descending order, you will get the highest salary as rank 1. And since we want first highest salary, we are giving as rank 1, so that it will retrieve the details like this. And here using subquery, we can write we can get the first highest salary by using this query also. Here what I am doing in the subquery, I am finding all the records which are less than maximum salary. And then with using a not in, I am removing all the records and only the record with highest salary is preserved. Similarly, to get the second highest salary in the company, I am using the same methodology, but here I am giving offset 1, so that I get the second highest salary records. In the same way for the subquery, what I am doing is I am checking for the salary less than the maximum salary. In previously I am giving salary equal to maximum salary, but here I am giving salary less than the maximum salary to get the second highest salary. And in the same way I am using rank function in Windows, and when rank is 2, you will get the second highest salary. Similarly, for third highest salary also, I am giving offset to the same query, and for Windows function I am giving rank 3. And the same way, if I wanted to use subquery, I can use the same kind of query before, but I am in subqueries, I am filtering the maximum salary 2 times so that I get the third highest salary. But we can even write a correlated subquery. Here what we doing is, we are selecting the employee details such that the count of distinct employee salaries in employee E2 alias, the salary is greater than the even salary is equal to 2. So what happens is, since we need the third highest salary, to get the third highest salary, that salary would be less than 2 salaries before. So that is the reason here the count is 2, and this is a correlated subquery. For every query, for every salary value, it will check how many number of salaries are like the count of salaries which are greater than the salary considered, and according to the count it will retrieve the third highest salary. To generalize these queries, so here to get the nth highest salary, we need to give limit 1 and offset n minus 1. But to get the third highest salary, because n is 3 here, here n minus 1, that is 2. In the same way, using the correlated subquery, what we are doing is, to get the nth highest salary, we need to give n minus 1. So, to get the third highest salary, where n is 3 here, so 3 minus 1, 2. To get the third highest salary, the count of distinct salary which is greater than that salary should be n minus 1, that is 2. Now we'll find the top n records. So far we are getting the only record which is top 5th or top 3rd. But now we want to find multiple records which are in the like top 3 range or bottom 3 range. So to find the top 3 highest paid employees, here we are not giving any offset. We are just using limit. And in the same way here, instead of count equating to one number, we are giving less than 3 number, so that all the records which fall under less than 3 category are also displayed. In the same way, for Windows function also, instead of we are equating rank directly to a number, we are giving less than the rank, so that all the records are displayed which are below that rank. And similarly, to get the bottom 3 lowest paid employees, the procedure is same, but here we are ordering salary in ascending order. Instead of before we are ordering in descending order because we wanted highest paid, but here for lowest paid we are not. We are just ordering salary by ascending order by default. And here by Windows function also, to get the bottom 3 lowest paid, here in rank function we will order salary by ascending order, and we need to display all the records below or equal to 3. We are giving this condition, rank less than or equal to 3. And in the same way, if we want to, previously we are using or ranking, we are getting top and in whole employees table, but here we want to find department wise and the highest queries. So to find the highest salary in each department, we can write a simple straightforward group by where we get department and maximum salary. But in order to get the employee record details along with the salary, we are using a subquery here where the e.salary is maximum of salary and the department is equal to the department which we are getting from the outer query. So in this way, for each department, it is giving the maximum salary. And in the same way, we are using Windows function and the same rank functions, but here we are using partition by department to find the department-wise highest salaries. And to get the top 2 salaries per department, in the same way as previously, instead of equating the count or rank to a single value, in order to display all the records to be displayed below this category, we are giving less than symbol. Here also rank is less than or equal to display all the records following which are falling below that value. And when we want to find department with highest total salary paid, so we'll write the same group by department and by descending limit 1. So here we are using a simple group by function. So real business examples will be to get top 5 customers by revenue, top 3 products by sales, top n expensive orders, and top n departments by headcount. And finally, we'll find top n% salaries, like find top 10% of highest salary and find top 30% salaries. Let's see how it is. So to get the top 10% highest salaries, what we'll do is we'll be using this NTILE function, and here we have given 10. So NTILE 10 divides all employees into equal groups, and group 1 is top 10%, group 2 is next 10%, and so on. So here when we are giving the sal percentile as 1, it is the top 10% of highest salary, and in our employee table this is the top 10% highest salary. And similarly, when we want to find top 30% of salary, in NTILE, your records are divided into groups. Here we want to find the top 30% sale. We are using this function cumulative distribution, and then we are ordering by salary descending, and we are giving the percentile as 0.30. Here it won't divide number of records, but it will divide as per the percentage, and the top 30% salary are like this. And here for real life examples are top 10% performers, which we need for benchmarking, HR benchmarking, top 5% highest paid employees for compensation analysis, top 20% salespeople for sales incentive or bonus calculation. I hope this helped you to understand the top end queries. Thank you so much.